Hi, I'm the Chief Security Officer of my network, and my network is actually a decentralized data lake that's aimed to protect the data, and our technology focuses in for homomorphic encryption. We are actually using privacy computing and end-to-end encryption to protect the user privacy data. So let's today explore the mine network and then have a look at our solution to the data protection. Yeah, before introducing our products, I would first introduce our team. Actually, all of our team members are from top-tier universities or top-tier companies. Yeah, actually, most of them are from both. And Dr. Mason and Dr. George are our founders. And Dr. Mason is a fellow member of the Ethereum Protocol Fellowship. And Dr. George, he was actually a professor of cryptography. Before joining Web3, I was a security researcher and an entrepreneur. Actually, I was a co-founder of a security research company, and our company was famous for their security research achievements in Tesla, in iPhone. We compromised that Tesla Model S and iPhone, maybe iPhone 7, iPhone 8. So we were noticed by some big companies and finally purchased by Tencent. And it's currently part of Tencent Security Lab. Yeah. Yeah, back to our mine team. Actually, besides doing our products, we also are working actively in the Ethereum research community. Our research team recently released some papers regarding the topics of about for homomorphic encryption, witness encryption, and stealth address, cross-chain bridge, etc. Yeah, that's our team. And okay, let's come to the topic of data security. Actually, since the early age of internet, data breaches has always been a pain in the back. Yeah, we witnessed a lot of data breaches, and even in this year, we have some famous companies, for example, ChatGPT, leaked the user payment data, and MetaMask leaked their customer support data. Yeah, actually, that's only in this year. Why we can't fix the problem of data breaches? I think one of the most problem comes from trust. In traditional Web 2, we have to trust the centralized platform, and all of the users have to hand over all their privacy data to the platform, and then finally the platform gets compromised, no matter from inside, from outside, by exploiting vulnerabilities or by phishing. No matter what, the data eventually gone to the black market. So that's the problem we are facing. And now we have come to Web3. Web3, it's actually natively not that compatible with the privacy protection. Because as we know, the blockchains, they are actually open ledgers. And this means this means that the consensus it was established based on the plain text. They are just transparent plain text data, and then there is nothing to do with privacy when everything is transparent and open to everyone, right? So in this scenario, we need encryption, so we can turn the plain text data to ciphertext. And luckily, in Web3, every user, they have their own wallet, which contains a unique private key. This means that we can take that encryption solution one step further, because we have private key in the client side. So we can do end-to-end encryption. This means that all the data was encrypted in the client side, and it will never appear anywhere else besides the data owner. The data owner itself, its own client. Yeah. So we call that end-to-end encryption zero trust data. This means we do not trust anyone else to keep our data to transfer our plain text data. And the plain text only exists in our own side. And but that brings up a problem that because data loses value if it can be processed, can be computed, can be calculated, it loses value. However, when in traditional encryption solution, we actually need to decrypt the data first before compute on them. That's in the traditional scenario. That works well in a centralized Web 2 because we all have to trust the central platform, right? So the platform can decrypt our data, and then they do some computation on our data. However, in Web3, in typical Web3, we are decentralized, and no one will be trusted to handle our plain text data. So this means, so in this situation, we need privacy computing. Actually, in my network we are using full homomorphic encryption. So the data can be calculated over plain text. It doesn't need to be decrypted first to be calculated. So using this full homomorphic private computing solution, we call it zero trust computation. And zero trust data and zero trust computation, they are just the two major components of our zero trust framework. And that's we mine network. That's the solution we mine network delivered to protect to data protection. Yeah, this is the landscape of our mine network. In the central part, this is Mine Lake. Mine Lake is the core part of the mine network. It is responsible for the calculation and the storage of all the ciphertext. And beside it, there is a mined query. And mined query works as a gateway. Users can use the mined query to connect Mined Lake and utilize the features, the functionalities of the Mined Lake to do the privacy computing and the encryption storage. Yeah. And we also have MineScan. It is actually exploring tool. Users can use MineScan to access to view the transaction logs and the account infos for etc. And last month we have already released the Mined Lake SDK, and the developers, they can just import our Mined Lake SDK into their DApp, so that their DApp can directly communicate with our Mined Query and utilize the privacy computing functionality of our Mined Lake. Yeah. And then we will talk more about the Mined roll up. We actually roll up our we provide this solution and this functionality to the developers so that their end users can just employ our module called data pack, and they can use data pack to archive their data to Arweave. Yeah, let's look at this diagram. The users, they can visit the PermaWeb application. And in this application, the developers, they can import our Mined Lake SDK so that this application will be able to communicate directly with the Mined Lake, so that the users can use this application and to process his own data, just like a traditional dynamic website. Yeah, we can do this on this application. And when they have done processing their own data, they can archive their data to Arweave network. Actually, currently we are using the AR seeding solution. We use this data pack. The data pack can migrate a part of data which just selected by the user and migrate it to the AR seeding and then finally to the Arweave network, so that this data was processed and encrypted. Actually, the data archived to the Arweave network was ciphertext, and only the data owner will be able to decrypt this data and get the plain text. And when the user wants to do some calculation again over this kind of data, he can again use the mined data pack and import the data back again to our mined lake. Then he can again, just like doing the jobs in traditional database, just like that, he can use SQL to process this kind of data. And yes, that's the full cycle of data come back and forth between MineLake and the Arweave network. Actually, I decided to do the demo. However, I think currently we do not have this condition. So I will just describe our use cases. One is we have the MindX. MindX is actually application. It is developed over MindLake, my network, and it can be used to connect to different AIGC model, and its function it can keep the prompts, the memory of the conversation history, and encrypt them and keep them into the storage. Meanwhile, all the data, all the encryption is in the full control of the user themselves. And also we have the archive functionality, and this data can be archived to the Arweave network. Yes, in MindX. And we have also several other use cases. For example, we are using MindLake to store the verifiable credential, because usually the verifiable credentials that the owner won't. He doesn't want the verifiable credential to open to the public, right? So it can be directly put onto the blockchain. And in MindLake, those verifiable credentials can be encrypted and keep in the storage, and only the data owner, the user himself, can decrypt and fetch back his verifiable credential and give this verifiable credential to the verifier when he want to do it. Yeah, so that's our another use case of the verifiable credential. Yeah, that's all. So if you are interested in our solution, you can view our website or just follow our Twitter. Yeah, thank you.